This is Pre-Calculus Chapter 3, Section 4, problem number 67. And in this problem, it says to use Descartes' rule of signs. So this is Descartes' rule of signs from the textbook, and it's talking about the fact that when we're looking at the number of variations in sign. So if I look at this problem here, the first term is positive, the second term is positive, but the third term is negative. This is a change in sign. It went from a positive term to a negative term. And then it was another negative and another negative. So there's only, in this polynomial, there's only one change of signs where it went from a positive term to a negative term. And it says the number of positive real zeros is either equal to the number of variations in sign, which we only had one, or is less than that by even whole numbers. Well, an even whole number means to keep subtracting 2. I only had one change, so if I subtracted 2, that would give me a negative amount, and I can't have a negative amount. This really is talking about the fact that if I had a lot of changes in sign, like if every other one changed, and so I ended up with something like 5, if I had 5 change in signs, well then it would either be that I had 5 positive zeros, or I had 3 positive zeros, or I had 1 positive zero. I would keep subtracting 2. And it's giving you an idea of approximately how many positive zeros you'd have. For the negative zeros, what you have to do is you have to plug in negative x into this function, change all of these x's to negatives, and then examine how many change of signs. So, there's only one sign change in p of x, so therefore, there's only one positive zero. But, for the negative x, I plug in a p of negative x, and now we need to simplify this. And remember that negative x to the 6th, well that's going to make it positive. And negative x to the 4th is also going to be positive. But negative x cubed is going to keep the negative sign. And then of course we've got negative x, which has a sign. But here we are subtracting a negative, and over here we're subtracting a negative. So all of these terms will be positive, and the only one that will be negative is the last term. So p of negative x, it looks like this. And how many change of signs do we see? Well, there's only a change of sign from this positive 5x to the negative 1. So there's only one sign change, and therefore there's only one negative 0. Now, remember, this is a 6th degree polynomial, which means there's got to be 6 zeros. But Descartes' rule of sign tells us there's only one positive real zero and only one negative real zero, which means, since there has to be 6, there's 2 real zeros, and the other 4 zeros will be complex zeros. So that's an important thing that the Descartes' rule of signs can help us with when we start, in the next section, start actually finding these complex zeros.